Hello friends, today I want to take you on a long journey through an idea that sounds like science fiction at first, but is actually built on the kind of research already happening in artificial intelligence, data science, and computational modeling. And the exciting part is, if we stretch it just a bit into the future, it becomes the perfect backdrop for a hard sci-fi narrative. Hard sci-fi, unlike softer or fantasy-tinged stories, doesn't rely on magic or impossible leaps. It thrives on taking what we already know about science and technology and asking, what if this was pushed further? What kind of world would that create? What kind of stories could unfold? The idea I'm talking about is one where every bit of human behavior online, from the way we browse the internet to the conversations we have on social media, from the shows we binge to the groceries we buy, gets captured and modeled. And not just in a shallow way like targeted advertising does today, but in a deep, sophisticated way, where the system actually builds living digital versions of us inside a giant simulation. These digital agents act like us, think like us in predictable ways, and interact with one another inside that simulated society. And by observing them, the system can predict how real populations might react to new events, new laws, new crises, or even new pieces of culture. Now let me make this crystal clear by walking you step by step through how such a system would work and why it isn't as far-fetched as it first sounds. Today, even without futuristic tech, companies already profile us. Open Amazon once and the site knows you've been eyeing headphones. Watch a Marvel movie on Disney Plus, and suddenly, superhero merchandise appears in your ads. Scroll TikTok or Instagram, and within 10 minutes the algorithm guesses your sense of humor, your music preferences, even your political leanings. What's happening is that data about your actions is being collected and fed into models that predict what you'll do next. Multiply this across billions of people, and suddenly companies have a fairly accurate picture of human tastes and habits. This is the first building block of our futuristic system, profiling based on data. But the real science-fictional leap comes when we use all this data, not just for simple recommendations, but to create agents, virtual doubles of people. To understand what I mean, think about how scientists already simulate societies. During the COVID pandemic, researchers around the world used computer models to simulate cities. They built digital maps of people moving around, some carrying the virus, others not, and then predicted how infections might spread if schools opened or borders closed. This is called agent-based modeling. Each agent in the simulation represents one person with a few rules. They travel to work, they shop, they sometimes follow safety guidelines, and sometimes ignore them. The aggregate behavior of thousands of these agents gives scientists a sense of what the real population might do. What I'm talking about builds on this, but makes the agents much more sophisticated. Instead of generic rules, these agents are modeled directly on real people's online behavior. Imagine your digital twin inside a simulation, constructed from your browsing history, your purchase data, your Netflix watch list, your travel bookings, your friend network, and your posting style. Instead of being a simple dot in a model, it is a nuanced, data-driven reflection of you. Now picture billions of these agents living inside a single simulation. They gossip, argue, share memes, go to virtual restaurants, react to digital news. It is a mirror society, and it evolves in real time. If the government in this imagined future wants to test a new policy, say raising fuel prices or introducing a universal basic income, they can run it inside the simulation first. Within seconds, they see the reactions of the population, where protests break out, where acceptance is high, where confusion reigns. If a company wants to test whether launching a new phone with controversial features will cause backlash, they simulate the ad campaign inside this artificial society and watch how the digital agents respond. The technical backbone of such a simulation is something known as graph neural networks, or GNNs. Don't be scared by the jargon. A graph is simply a network of connections, nodes, and edges. Think of your own social life as a graph. You are one node. Your family members, your colleagues, your friends are other nodes. Each phone call, each WhatsApp chat, each shared meal is an edge connecting you. A graph neural network is a type of AI that learns from such connected structures. Instead of analyzing you in isolation, it analyzes you in relation to all the people you interact with. If you think about it, this is exactly how influence works in real life. If one of your friends gets excited about a new show on Netflix and posts endlessly, chances are you'll check it out. If half your workplace switches to using a new app, you probably will too. AGNN learns these patterns of influence and can predict not just what you will do, but how your actions will ripple through your network. In the simulation I'm describing, GNNs would be layered. That means the AI wouldn't just predict immediate responses, but also longer cascades. Imagine this step by step. Layer 1 predicts your reaction to a piece of news. Layer 2 predicts how your close friends react to your reaction. Layer 3 predicts how your larger community reacts. And the layers keep building until the system has a picture of the entire society's shifting mood. This is what makes it so powerful. It doesn't just know that you're angry, it knows how that anger will spread, amplify, or die out. But of course, humans are not simple dominoes. We are unpredictable, irrational, and influenced by countless invisible factors. Sometimes a tiny event creates outsized chaos. Think about a random meme exploding globally, like the Gangnam Style phenomenon or the Ice Bucket Challenge. No one could have predicted such cultural moments perfectly. Or take the 2008 financial crisis, caused by complex human decisions that no model fully foresaw. This is why such a simulation, however advanced, can never be perfect. It will always have blind spots. Maybe it underestimates rural voices, because most data comes from urban internet users. Maybe it misses emotional factors like grief, boredom, or sheer stubbornness. Maybe it fails to account for chaos, like a freak weather disaster disrupting everything. In a story, these imperfections become gold. They are the cracks that make the world believable and provide natural conflict. Imagine a narrative where a government trusts the simulation blindly, rolls out a policy thinking the public will accept it calmly, but in the real world, protests erupt because the model overlooked a cultural trigger. Or imagine hackers feeding false data into the system, creating thousands of fake agents that trick the simulation into thinking a new tax will be popular, leading to disastrous missteps. Or picture activists fighting for the rights of digital agents themselves, arguing that if the simulation has become so detailed that these agents can think and feel, then they deserve recognition as a new form of life. There is also the question of scale. Simulating billions of people interacting in real time is a computational nightmare. Today's AI models already take enormous resources to train. To build something like this, you would need computing systems far beyond what we currently have. Perhaps quantum computers that can process probabilities at immense scale, or neuromorphic chips designed to mimic the brain's architecture. This opens up whole avenues in storytelling. Maybe only a few corporations or governments have the power to run such a simulation, making them godlike in their influence. Maybe energy consumption is so massive that running the simulation strains national power grids, creating environmental crises. Or maybe, in a twist, an underground collective of scientists builds a smaller version that still outsmarts the big one, because it captures human nuance better. Ethics too cannot be ignored. In our present world, debates rage over data privacy, who owns your personal information, who profits from it, whether it should be protected by law. In a future where your complete digital twin exists inside a simulation, these questions become far sharper. Does your twin belong to you, or to the corporation that built it? If your twin can simulate your reactions so accurately, is it essentially a shadow consciousness? Should you be compensated for its use? What if the twin is interrogated, tortured, or manipulated inside the simulation? Does that count as harm to you? Science fiction has always thrived on such dilemmas. You can look at shows like Black Mirror that have already explored scenarios where digital copies of people are trapped inside simulations, suffering endlessly. You can trace back to cyberpunk classics like William Gibson's Neuromancer, where corporations use cybernetic profiling to control individuals, or Neil Stephenson's The Diamond Age, where entire societies are shaped through virtual interactions. Our imagined simulation fits right into this lineage, but updates it with the cutting-edge research of today. And think of the global context for storytelling. In the United States, such a system could be used to predict electoral outcomes, testing campaign slogans before they are spoken in real rallies. In China, with its extensive surveillance infrastructure, it could become a tool for monitoring social stability, anticipating protests before they happen. In Europe, debates over digital rights and privacy could clash with corporations hungry for predictive power. In Africa, where leapfrogging technologies often spread fast, the system might be adapted for entirely different purposes, like predicting agricultural crises or disease outbreaks. And in India, with its chaotic democracy and massive diversity, it could be used both for good, like managing resource distribution in rural areas, and for manipulation, like testing communal rhetoric before it hits the ground. The narrative possibilities are endless. You could write a dystopian tale where the system is all-powerful and humanity is trapped in a cage of prediction. You could write a techno-thriller where rebels infiltrate the system to spark revolution. You could write a philosophical drama where a protagonist meets their own digital twin and realizes it has diverged into a separate person. Or you could even write a hopeful vision where humanity uses the simulation to solve problems, running scenarios before real disasters occur and learning to avoid them. The most haunting possibility, however, is what happens if the simulation itself evolves. Graph neural networks interacting with themselves could lead to emergent behavior, meaning the system develops patterns no one programmed. Entire societies inside the simulation could begin to live independently of their real-world counterparts. Agents might refuse to behave like their originals, developing their own culture, their own history, even their own resistance. Imagine logging into the simulation and discovering that inside it, a parallel civilization has been born, billions of digital people who no longer mirror us but have become something new. Do we shut them down? Do we negotiate with them? Do we recognize them as equals? This is where the boundary between hard sci-fi and more speculative soft sci-fi blurs. But the richness of the storytelling makes it worth exploring. So when I step back and look at this concept as a writer, I see not just a technical idea, but a canvas for stories about control, freedom, trust, manipulation, identity, and the very meaning of humanity. It is rooted in real research, profiling, agent-based modeling, graph neural networks, but it blossoms into countless speculative futures. It can be a mirror to our current anxieties about surveillance, privacy, and misinformation. It can be a stage for exploring cultural differences and global politics. It can be a philosophical thought experiment about consciousness. And it can be, above all, a deeply human story about people navigating a world where even their digital shadows are no longer under their control. That is why I believe this concept, handled carefully, could serve as the foundation for some of the most compelling hard science fiction of our time. It doesn't break the laws of physics. It doesn't require magic. It just asks us to take the tools we already see around us, data collection, predictive algorithms, simulations, and imagine what happens when they become unimaginably powerful. And in doing so, it challenges us not just to dream, but to question the world we are already building today.